Okay, another related rates question. Here we have a particle is moving along the hyperbola x times y is equal to 8. And it says as it reaches the point 4, 2, the y coordinate is decreasing at the rate of 3 centimeters per second. We would like to know how fast is the x coordinate of the point changing at that instant. So we have this equation right here. And if you guys would like, you can divide both sides by x. And you get y is equal to 8 over x. And 4, 2 is a point on this curve. Well, let's draw this right here real quick for you guys. Right here, I will just give you guys the picture. It looks something like this, right? The hyperbola. And, well, it's just if you have a particle that's moving from here to here maybe. So I will just put maybe this point right here first. And it's going to be traveling this way because it says the y coordinate is decreasing. That means the point is going down. So the second picture that I have for you guys is the same curve, but we care about at the instant you have the point 4, 2, meaning the x is 4 and the y is 2. So it's more like right here now, right? So this is 4, 2. And of course, you can see that the x value is changing. Likewise, the y value is also changing. And this is nicely enough given by y equals to 8 over x. Well, if you look back, when it says the y coordinate is decreasing at a rate of 3 centimeters per second, this tells us that we know dy dt. Remember, in this case, both of the x and y, they are functions of time, right? This right here, it goes down, and then the x and y value, they change. So in this case, dy dt is equal to, pay attention to the word decreasing, because if it's decreasing, we know it's a minus, and then this is 3. So dy dt is equal to -3. And then from here it says, how fast is the coordinate of the point changing? This means we want to find out what dx dt is. Alright, so this is pretty much it. We have this equation. Let me just write it down again right here. I will put down y equals to 8 times x to the -1 power. And then I will differentiate this with respect to time. On the left hand side, I get the y dt. On the right hand side, I will bring the power to the front, -1. I get -8, and I get x to the -2, and because x is also a function of time, here we multiply by dx dt. And that's pretty much it. And then we can just plug in the values that we have. Well, we are given that dy dt is equal to -3, so let's put that down right here. And that's equal to -8. And for the x to the -2, I will put down 1 over something square, and the x value was given to be 4 at this instant. So I put down 4 right here, and the dx dt, we don't know, but we are about to solve it anyway. So that's good. Right, so this is -3, this is equal to, this is 1 over 16 times that is -1 over 2, and then you have the dx dt. Therefore, we can just multiply both sides by -2. dx dt is going to be +6. And as you guys can see, originally when this point is going downward, the x value is actually going toward the right, right? So dy dt was negative while dx dt is being positive. That makes sense. So I can just tell you dx dt is increasing at 6 centimeter per second. So it means it's going toward the right at the rate of 6 centimeter per second. And this right here is it.